would like to introduce myself first. So I'm Trixie Estomata. I studied geodetic engineering and I took a master's in remote sensing from the University of the Philippines, Pacific. So my thesis was actually benthic cover mapping for video tours and photos. So it's very perfect for SOMACORE and their topic of, coastal resources mapping. So I've been, as Trish mentioned, I've been with GIZ since 2013. So I've worked for more than 8 projects, working on different environmental and climate change topics. My current position is the Senior Technical Expert in Digitalization and GIS. And I had some short stints with JICA, Fauna International, and also NEDA. And my hobbies are baking for fun and also playing badminton. So that was a very short introduction about myself, and now I jump into the actual talk. And also I want to give a context on where this mangrove survey study was done. So this was part of the Ecosystem-Based Adaptation in Two River Basins, or the E2RB project. So we had 2 sites. One was in Visayas, which was in the middle of the Philippines. So I hope my laser pointer is viewable. So it's here. And the other one was in Mindanao, which was in the south of the Philippines, which was in Tagum-Libuganon River Basin. So there was a project reporting required for our donors, and it required information on various natural resources or ecosystems within our 2 river basins. Essentially, we needed to report on the amount or the length of coastlines with mangroves. We had to provide that in kilometers. And then we also had to report like the amount of forest, bush, or shrubs mosaic in our sites, and also the amount of mangroves that are in the 2 river basins, also in hectare. So the issue was that there was very inconsistent information from various data sources that we could get our hands on. We, at the time, because the project was implemented from 2019 to 2024, and the baseline, the first information that we needed was supposed to be for 2020. And at that time, the national map was still not available for public, and it was still for finalization. So we had to use an old data set from our national mapping agency. We call it NAMRIA. And it was for the year 2015. So, and then we also looked into a global map called the Global Mangrove Watch. It was sharing information about mangroves globally for the year 2016. And then for the Philippines, there was an initiative from the BMUKN project, which used the mangrove vegetation index and mapped mangroves for the year 2019. And eventually, I think maybe in 2022, this S3 plan meter land cover data became publicly available. And on the right side, you see some maps. So you see here on the upper part for Ilog Hilabangan, the different data sets are available and placed on top of each other as layers, and you see that there's a large discrepancy among them. And what's actually more upsetting at the time was for Tagum-Libuganon River Basin, the global estimates didn't show, or the global maps didn't show any mangroves in Tagum-Libuganon River Basin. So we were very surprised to actually get our hands on a global data set, but it didn't reflect the reality that there were mangroves in the river basin. So, so that was an issue there, that for our local maps, the ones generated by NAMRIA, or our national mapping agency, reflected river basins all over the Tagum-Libuganon River Basin. And when I also double-checked this with Google Earth satellite images, there were some very high resolution. I could determine that there were mangroves there. But in the global data sets, it was missing. So we were like, what's wrong with this data? So, and also there was a part there that was very, very difficult to identify if it was mangrove or if it was just a bunch of trees or whatnot. But on the NAMRIA maps, it was reflected as mangroves. So these were some very difficult information that we could not derive from available datasets or from just looking into more recent satellite data that was available for free. Other than that, for Ilog-Hilabangan, although in all three datasets, also the global models showed mangroves, the areas that they estimated were very different. So for I think for the land cover map from Manila, it was 880 hectares. For other global models, it was around 625 hectares. But for the blue cares, using the mangrove vegetation index, it was 2,000 hectares. So we were like, okay, which one do we use? So in the end, Google Earth pro satellite images, which were usually helpful to confirm or validate the land cover, if it's mangrove or not, if it's grassland or not, if it's water or not. It was very difficult to infer from it in this case, except if I have been to the area itself, like in the following example. So I just show you some satellite images where I have been to the sites and I can confirm that they are mangroves just based on the satellite data. So here, this is Balingasay River in Bolinao, Pangasinan. This is on the north of the Philippines. And this river is bordered by very large mangroves. So on this satellite, it's a little bit far. But if you zoom in on these areas, you will really confirm that these are mangroves. So that's easy. Also in the Carmen Siargao Island, which has one of the largest contiguous mangrove areas, you will see this as satellite images on Google Earth, and it's very clear that these are mangroves. And also for Siargao specifically, it was very easy to determine mangrove and beech forest just based on satellite data. So you can see here on the middle, this is actually the bright green is beech forest, while the rest is actually mangroves. And also the same for, in this case, this is also in Siargao. On the left, the dark green is mangroves, while on the right, mostly beech forest. But yeah, so in the case for our two sites in Ilog-Hilabangan, especially in Ilog-Hilabangan, the site in the middle of the Philippines, it was very difficult to conclude just based on satellite images. So we still had to visit the areas and really confirm the presence or absence of mangroves. So our approach was, we just need to confirm if the mangrove is present or not. And we needed the geolocation, latitude, longitude. We took some photos to confirm it is a mangrove or not, because you might say it's mangrove, but then apparently it's not. So I think this was proof for our boss then that this is actually mangrove, because he was also a mangrove expert, our boss for that project. So he also wanted to get the species name, the height estimate, photos of the whole mangrove, the leaves, its flowers, because he wanted to cross-check if the species identification was correct, which he actually didn't have the time to do. And so, this was on the right. You see, this was actually the very, very simple survey questionnaire that we implemented, or we tried to use in the field. And we could have done it using paper and pencil or pen. We could have used a GPS instrument, camera, a mobile phone with geolocation, geotagging. But at the time, we wanted to try if Kobo Toolbox would actually work. And this is how it looks like. It looks like if you're using Kobo Collect, which is the app that you use on your mobile phones, and this is how it would appear. So essentially, there were predetermined points. We asked them to identify which point they were trying to visit. We asked them to collect the GPS location, if they actually went to the point or they just viewed it from afar, especially if it's not possible to reach the point. And then we asked them to identify the species, the height, and then the photos, and then some remarks. That's it. That was as simple as we needed. If I would have been the only person who had to use the data, I would have stopped at, is mangrove present or not, yes or no, identify the location. And that would have been my form. But at the time, we wanted to also know which specific mangroves were present in the site. So also part of the approach was that we coordinated a lot with the local government units and other stakeholders. So we coordinated with the Provincial Environment Office, the City and Municipal Environment and Natural Resources Office, the barangay captains. Because one site was in a private property, we had to coordinate with a private company called IHO. And we requested the presence or attendance of a mangrove identification expert in both sites, or at least someone who was familiar if a plant is a mangrove or a non-mangrove. And then we organized prep meetings for mangrove identification experts on what is the purpose of the field exercise and how to collect using Kobo Collect. So on the upper part, you see Ilog-Ilabangan River Basin, and these were the points that we visited. And on the bottom, you see the Tagang-Liboganan River Basin and the points we targeted to visit as well. So both 50 points. And then we eventually found out that 6 out of the 50 points for Tagang-Liboganan, which is 15%, were actually non-mangroves. And in Ilog-Ilabangan, most of the points along the river systems that were far from coastlines were covered by a mangrove associate called Nipa palm, and only river outlets of Ilog-Ilabangan had true mangrove species. So we were able to confirm in this field work that the large area of the mangroves in Tagang-Liboganan from the 2015 land cover was actually beech forest. So this was identified. This you see on the upper map, the purple large area. I think this is around 100 hectares. I think it was identified as mangroves in our national map. But yeah, when we went to the field, apparently like a large portion of it was beech forest. So we were able to identify that on site. And the other good to have information that we were able to obtain for these fieldwork was that we were able to identify that there were 3 major species in the site, and that the average height was very different. So in Ilog-Ilabangan, they were younger and smaller, around 3.5 meters, and in the other site, century-old, very, very tall, maybe more than 7 meters, probably some of them. And on this slide, you see a photo on the left. So you see one of the staff from the Provincial Environment Office there standing at the bottom of the mangrove, and these were the mangroves there. So very sizable, very old mangroves along the coast, and estuaries and vast areas of intact mangroves still exist in some parts of Tagang-Liboganan. And then for Ilog-Ilabangan, apparently they're younger, smaller, because of they were just recovering from the effects of a recent typhoon. So the photo at the bottom, you see that locals confirmed that these mangroves used to be very thick and very tall, but a typhoon, we called it Otdet at the time, had damaged them, leading to mangrove degradation. So just some lessons, challenges, and also some lessons learned. So local knowledge is crucial. We had to ask locals to cross-check the areas that you want to visit. So in our case, we predetermined some points, and apparently they already knew that the points were not mangrove. And we could have just asked that, but we didn't really properly coordinate, also because I think we only found late about who would accompany us to the field. So that would have been more efficient if we knew ahead of time. Also, ask about the access when you go to the field. Are you going to be able to get to the point using a boat, a car, by foot? Is it safe to do field work? So I mentioned before that some points were difficult to visit because it was in private properties, or apparently there was a water body from where we were, and there was no way to cross the other point. So it was there were some cases like that. And yeah, prepare ahead if access is difficult, road conditions, or if it's not possible. Like, for example, if a property is private. So if we had not coordinated early on about accessing the area for the Iho, it's a resort actually. So we had to do a lot of preparatory meetings just so we could access their area and do some field work. Also, ask local weather patterns, especially during rainy season, if roads are accessible, or if you need boat rides, or if it's safe. In another case, it would be very important to plan ahead your if an area undergoes very high tides or very low tides, because I have heard about stories from other colleagues who went to the field and pushed um, this timing of high and low tide, and there were times that it was very challenging to leave their mangrove sites. And lastly, the mangrove identification expert that was with us. In this case, it was this guy holding this pink bottle. So he was the mangrove expert then. Was very critical for the success of the field work. And just some conclusions and recommendations. For the EPO project, our direct outcome was that we obtained updated 2022 and validated mangrove information for our two sites for reporting purposes. So it was not really for to make updated maps, but it was more of like an internal reporting for us. An indirect outcome is that we showcase the tool that could help or assist our partners in future field activities, especially in areas that do not have Wi-Fi, internet, or signal reception. And for our partners, the information gathered from the validation survey informs them on the state of their ecosystems, whether it's intact, degraded, denuded, and where to focus their conservation efforts. And yeah, Kobo Toolbox for various purposes or applications were presented to our partners. And here on the right is technically the direct outcome, like we were able to update the NAMRIA 2015 land cover map and also confirm that the global estimates were wrong and that we had a large area of mangroves in Tagolibuganon.